Guys, welcome to Tebby Talks, Expedito again. In this video, we are going to learn how do we calculate percentage yield. Now, in calculating percentage yield, we go through a series of steps that I will first list for you. Steps taken. Step number one. Step number one, you must first determine the limiting reactant. Determine the limiting reactant. Step one is saying that you determine the limiting reactant. Step two is write a well-balanced equation. A well-balanced equation. Step three, then calculate the theoretical yield. Calculate the theoretical yield, and finally you calculate the percentage yield. Calculate the percentage yield from percentage yield equals to actual yield of theoretical yield times 100%. So these are the steps that you must follow if you should calculate the percentage yield of anything so accurately. These are the steps we take. So let's try to calculate our percentage yield in this case here by taking the steps that we have listed here. Now we are saying the first step is determining the limiting reactant. But the question is, how do we determine the limiting reactant? We said we determine the limiting reactant from that reactant that has the least number of moles, then that is the limiting reactant, and that's what we use to calculate the amount of product that is produced. So let us begin. They are saying what mass of aluminium chloride can be formed from aluminium and chlorine. So we have two reactants, aluminium and chlorine. These are our reactants. Now, how do we determine number of moles of aluminium? So here we are going to say number of moles of aluminium. We know that number of moles is mass given over the RFM of aluminium, which is 27. Let me get my calculator. 34.0 divided by 27, we get 1.259 moles. Let's also get the number of moles of chlorine. The number of moles of chlorine. Now, the chlorine, in this case, they gave us a volume that is occupied and at STP. So, still, from first principle, number of moles of chlorine will be volume occupied by chlorine divided by volume occupied at STP. So, when I do that, again, plug this in the calculator, divide by 22400. This gives me 0.55 moles. So from this, we say that the limiting reactant is that reactant that has the least number of moles. So now, from conversion here, guys, I guess we all see that this is the least value, so therefore chlorine is the limiting reactant. Chlorine is the limiting reactant. Now, we have known the limiting reactant, and I say we use the limiting reactant to calculate the product that has been formed from such a reaction. But we said step number 2, you should write a well-balanced equation. Therefore, we are going to write an equation of reaction between aluminium and chlorine gas. So it is supposed to yield aluminium chloride. So we balance this equation, that is 3, it becomes 6, 2, and 2. So this is our equation of reaction. Now, we said that the next thing now is we are going to use our limiting reactant to determine the amount of product that is formed, and our product was aluminium chloride. It was aluminium chloride. Now, here we have various ways we can proceed. We can either use moles. You remember the interpretations of chemical equations. You can use any interpretation you're comfortable with here. Whichever interpretation you're comfortable with, it will still lead you home. Now, let me use this interpretation that 3 moles of chlorine produce 2 moles of aluminium chloride. That is what we are seeing. So we see that from the equation of reaction, 3 moles of chlorine react to produce 2 moles of aluminium chloride. Okay? But how many moles of chlorine reacted? We had 0.55. Therefore, 0.55 moles of chlorine will react to give us 0.55 times 2 divided by 3 moles of aluminium chloride. So we plug that on the calculator. Plug that in the calculator. In the calculator, it gives me 0.3667 moles of aluminium chloride. Now, these are a number of moles, but our question asked for mass. The question asked for mass. We know the relationship between mass and number of moles. We know that number of moles is equal to mass over relative formula mass. So what is the relative formula mass of aluminium chloride? Aluminium is 23 plus 35.5 times 3. So this is 27. So my RFM here gives me 133.5 grams. So, but we are saying number of moles is equal to that. In other words, mass is equal to number of moles times the relative formula mass. Therefore, the number of moles here, this is going to be 0.667 times 113 times 133. So that answer, when we multiply, we realize that our mass is 48.95 grams of aluminium chloride. So that is the mass of aluminium chloride that is produced. So please, you remember the steps that what mass of aluminium chloride can be formed from this of aluminium and chlorine. Now remember, in this question, they have not asked us to calculate the percentage yield. But if they had asked for percentage yield, now this is what would have happened. They would have told us, let us assume. Now let us assume that the actual value was maybe 42.4 grams. Now if they had asked for now percentage yield, this would be percentage yield is equal to actual yield over theoretical or calculated yield. So this would have been 42.4 divided by 48.95 times 100. And you express that as of hours as a percentage, and therefore we would have calculated the percentage yield. But in the next example, we're going to see how do we calculate percentage yield.